Alright, so let's take a look at using Descartes' rule of signs. So it says to discuss the possibilities for the roots to the following. Now, when they say discuss, let's take a look at really what that means. We're not going to actually write words. We're actually going to show it in a chart form. Okay? So it's going to be something like this. Descartes' rule of signs says that the number of sign changes, okay, the number of sign changes, for instance, let me go through here and let's just color the positive terms, okay, and then let's color these negative terms. And it says this, that if a polynomial is arranged so that the terms are in descending order, right? The terms are in descending order. So this one has 4, 3, 2, 1, and no powers. Okay, those are the powers that we see. So if it's in descending order, then the number of sign changes, there's 1, 2, 3, 4 sign changes. The number of sign changes is the number of possible positive real roots, or less than that by an even number. So here's what I just found. I just found that there were 4 sign changes, and that tells me that there are either 4 possible positive roots, or less than that by an even number. What would that be? 2 possible positive roots, or 0 possible positive roots. Okay, so let me say that again. The number of sign changes, 1, because this was positive, right, to negative, that would be a sign change. Negative to positive is a sign change. Positive to negative, and then negative to positive. That's 4. So I write 4, and then I write the number that's less than that by an even number. So the next one would be 2, and the next one down will be 1. Now why don't I keep going to negative 2? Because this is the number of actual zeros that would be positive real zeros. Well, I can't have a number of items be negative. So I stop when I get to 0. Or if the next ones would be a negative number of items. So let's take a look now what we do to figure out the number of negative, the possible negative roots in the real number system, the real number of negative roots. Here's what we do. We take the polynomial and we substitute in a negative x. That makes sense, right? To find the number of negative, the possible, negative real roots. Now, think about how this could be really helpful. If I'm doing the PQ thing to figure out how many roots there are, I wouldn't have to go through, if I found out, let's say that a polynomial didn't have any negative roots, well then why would I do any negative options on the PQ, right? Why would I try any? I wouldn't. So this can really save us some time. So let's take a look. What I'm going to do now is I'm going to go ahead and simplify. In other words, I'm going to apply the 4th power to that negative x. Well, if I have negative x times negative x times negative x times negative x, well, I'm still going to get the 4th power, but it's going to end up being positive. Okay, now let's do, remember, powers have to come first. So negative x to the 3rd power remains a negative x to the 3rd power times the positive 4 is going to, times the negative 4 is going to be a positive, getting ahead of myself, x to the 3rd. Okay, this right here, negative x times negative x, is going to be just plain old x squared. I have negative 4 times negative x is positive 4x plus 8 equals 0. So now I've simplified it so that there are no parentheses. Now let's go ahead and take a look again. The positive ones I'll make yellow. Oh my gosh, look at there. Okay, so how many sign changes do I see? Well, I don't see any sign changes. no sign changes. No changes in sign. So that means I have 0. So I'm going to put 0 over here. Okay? But now, less than that by an even number, for the negative real zeros, or at least the options that we have, I can't do anything with -2. That's not a number of items. And so I'm going to have to just give the 2 an option to have 0 negative roots, and then the 0 has to have an option to have 0 negative roots. In other words, this thing doesn't have any negative roots. So that's very helpful to me. It doesn't have any negative roots. Now, what in the world is why did I make a third column? Well, remember, I have to have 4 roots, either in the real world or the imaginary world. Now, these two things are just talking about the real world. Well, what about the imaginary world, right? We have imaginary roots. So if I can only have a total of 4 in this polynomial, this only has 4 complex roots, meaning real and imaginary combined. Well, then 4 plus 0 means that I'd have no room for any imaginary if this is really what was happening in this polynomial. But I don't know for sure. That's one option that this polynomial could exhibit. It also could be that there are 2 real positive, 0 negative, and how am I going to get to the 4 that it has to add up to? I put 2 imaginary. So you notice each of these rows have to add up to 4. Okay, well, if it's this option, if I find out that there are no positive real roots, and no negative real roots, then what does that leave me? I have to have 4 imaginary. Well, we already talked about, look how the imaginary are ending up. We already talked about they have to either not be there, or they have to show up in pairs, don't they? So that makes complete sense with what we've been talking about. Okay, let's go quickly to the next one, and we'll take a look. How many sign changes? I have positive here, negative, negative. Let's see how many sign changes. 1. Now that's not a sign change from there to there because that's still blue, right? But then blue to yellow, there's another one. So here we go. Let me make my table. I have, for possible real positive roots, I'm going to have 2, or what? Less than that by even would be a 0. Now let's go ahead and put the negatives in there. Have you noticed that when it's raised to an odd power, it's going to change the sign, right? You should make those types of observations. So let's do this first. That's going to be a negative x to the third times the 3, and that's negative 3x to the third. In other words, it was positive and now it's negative. Because this is a squared, it's going to remain the same as it was before. There it was, and there it is. So if you start to see the pattern, you save yourself a lot of time. Okay? Alright, so how many sign changes? Let's look. I have a positive here and a positive here. I have a negative and a negative. Oh, look at there. I just see 1 sign change. So that means for negative, let me do this consistently here. So the negative ones, I'm going to have 1. Okay, let's finish out the chart. Okay, 1 has to have an opportunity to be paired with the 2 positive, 1 negative. Well, then how many would that leave me for imaginary? How many would it leave me for imaginary? Well, this thing is only to the 3rd power, so it wouldn't have any room for imaginary because 2 plus 1 is 3, and I can only have these equal 3, right? The whole row has to equal 3. Okay, so let's see. 1 or less than that by an even number, I can't put 0. That's not less than that by an even number, so this is just going to be another 1. I need to give the 0 an opportunity to have the 1 negative as well. Well, then what does that leave me for the imaginary column? Well, that leaves me that would have to be 2 in that row, because these, again, have to add to 3 across the row. Okay, I hope that was helpful. We made it in less than 10 minutes. Thanks for watching.